This is the Knowledge Graph Insights podcast, episode number 53. It turns out that contemporary explorations of hybrid AI are actually reopening conversations that started almost 70 years ago. In the early days of AI, neural network connectionists and symbolic AI researchers saw their work as naturally complementary. Out of that primordial AI ecosystem emerged Doug Lenat's Cyc project, an ambitious effort to account for all of humanity's common sense knowledge. Ben Rohde is now trying to bring that work to the RDF world.
Welcome to the Knowledge Graph Insights podcast, where experts on knowledge graphs and the semantic web share their wisdom with the digital and business communities. Our mission is to demystify and democratize knowledge graph technology and practices to make the benefits of knowledge graphs and semantic technology accessible to all. And now, here's your host, Larry Swanson.
Hi, everyone. Welcome to episode number 53 of the Knowledge Graph Insights podcast. I am really delighted today to welcome to the show Ben Rohde. Ben is a longtime ontologist, best known for his association with the Cycorp project, and we'll talk a little bit about that and the Cyc project in general. He's also working on, and the reason I wanted to have him on the podcast today, he's working on a project to port the Cyc attempt to account for common sense knowledge in the world into the RDF world that most of us are familiar with. So welcome, Ben. Tell the folks a little bit more about what you're up to these days.
Okay, so as in the course of finding my way to a new position, I'm working on several projects of my own. One of them, as you mentioned, involves trying to port as much as can be ported from the upper Cyc Ontology, particularly the 2014 version of that is in the public domain. It's available under public licensing on GitHub. To try to port as much of that as possible into the resource description framework and the semantic web. And this has actually become an experimental interest of mine, and I think it may be we can learn quite a lot from doing that.
Yeah, that's a good opportunity to remind me to ask you about like the history of all this. And it goes back, well, you did a presentation a while back that I saw where you kind of set out the overall like the history of the development of the field of AI and how Cyc and other things fit into it. Can you talk a little bit about that?
Yeah, well, I mean, I think the framing context there is partly the question of, well, why would you want to translate the upper ontology of Cyc into RDF, and what would that be good for, and really what perhaps there's even a larger question there of what would Cyc or the semantic web be good for in the current AI context. Now, I mean, I think the story here really is maybe much older than a lot of people realize. I mean, the roots of AI generally go back quite far, and here I think it's very important to distinguish between what we sometimes hear referred to as symbolic AI versus sub-symbolic. I think both the semantic web technology stack and Cyc can fairly be described as symbolic AI. Large language models are a good example of sub-symbolic AI, or sometimes referred to as generative or probabilistic AI. Now, I mean, it's really interesting that this really starts. For symbolic AI, it's really quite early. I mean, it starts back at the end of the 19th century, really, with what we might term as math validation. What you have here is a set of concerns coming up in the mathematical community that the foundations of mathematics might not in fact be sound, that there might be hidden contradictions, and certain developments, spearheaded, for example, by Bertrand Russell, it led people to believe that their worst fears might be realized. So, what you have developing in the late 19th and early 20th centuries is an effort to put mathematics on a sound foundation. And one of the things that comes out of this, not only is it symbolic AI, computing itself and digital computers and programming really have their origins within this thread. And then a little later than that, really starting up maybe in the early 1940s, you have information theory, which is coming with Claude Shannon. And then associated with that is a movement that has been almost completely forgotten now, and I think regrettably forgotten. It was called cybernetics. If I remember right, the name originated with the Greek Kyberos, hopefully I'm pronouncing this right, Kyberos, meaning steersman. I mean, the interest was in homeostatic systems, are systems where there was reentrancy of information and energetic cycling to maintain homeostatic conditions. And there was a belief that this could tell us a lot about a lot of things: physics, biology, information science. Some of the key names there are Norbert Wiener, Heinz von Foster. Let's see, I think it was, I believe Umberto Maturana and Francisco Varela, and also a guy named Hans Jonas, who I've only recently found out about, and I'm starting to believe beat everyone to the punch on that. But this is the thread that in some ways gives rise to generative AI. I mean, it comes through things that were called perceptrons that were pioneered by Warren McCullough and his student Walter Pitts. And so, but an interesting aspect of it is that when you go back and look at some of these writings, particularly Norbert Wiener and Claude Shannon, one of the things that really comes out is they were talking in terms of complementarity. They were talking in terms of what we would call symbolic and sub-symbolic AI complementing each other. Shannon was talking, for example, about auto-tuning versus code optimization. And if you think of auto-tuning roughly as kind of being the machine learning generative AI end, and code optimization being the symbolic end, those were seen as being mutually supportive. And I think that is a feature we really want to, we're at a point where we need to be re-examining that. I think that, it is being re-examined, under the heading of, we hear about hybrid systems or neuro-symbolic AI, and this really is it. We can talk some about what are the comparative strengths and weaknesses of symbolic and sub-symbolic AI in a little more detail, if you like. But I think
I love that too, that everything you just said goes back, because virtually everybody else I've talked to kind of marks that 1956 Dartmouth conference as the dawn of AI. Well, that's where McCarthy coined the term.
That's AI. Where McCarthy coined the name. Yes.
Yeah, but also it just occurred to me duh, that didn't just come out of nowhere. And in fact, I talked to our mutual acquaintance Pat Hayes about the origin of that, and he said, yeah, the whole notion, the coining of the term artificial intelligence was to distinguish it from cybernetics.
Exactly. And McCarthy at the time, 1956, he was sort of the young Turk. And Norbert Wiener was the graybeard, and again, there may be people in the audience who know much more about this than I do, but based on the accounts I have read and what I have heard, McCarthy was kind of concerned that if Wiener was in that conference, cybernetics were going to dominate, and he didn't want that to happen. He wanted it to be about symbolic AI. So, folks, not only Wiener, but McCullough and Pitts were kind of cut out of that discussion. And in some ways, that may have been a little unfortunate. I think the history might have been very different if there had been more interaction and more communication between those communities.
Yeah, because it's just now it's like, what, 50 years later, we're circling back and like, I don't know, probably, 10 or 20% of my podcasts over the last 51 episodes have in some way addressed, or probably most of them have talked about the neuro-symbolic AI and treating it as like a new thing, that like a relatively new thing at least in the current architectures, is like the need to like rectify LLM shortcomings and to accelerate knowledge graph building.
Yes. Yeah, exactly. And you just identified, I think, what in the current context are the really important points. Now, let's be clear. Large language models are one of the most important things to happen in human cognitive studies. I think in the last century at least, they are very, very important, and it's not fair to say that, people talk about this as being like, on an autocomplete algorithm, which at some fundamental level, it is recursive autocomplete with probabilistic next token extrapolation. But it turns out you can accomplish a heck of a lot more with that than anybody ever thought. A lot of people thought you could. So, some visionaries, I think, did see the potential. In fact, if you go back to Claude Shannon's, where even in 1947 he was publishing what amounted to a version. In his work on information theory, he was publishing what amounted to a version of that algorithm. But yeah, it is true that what you are getting, even when you are using it to get insightful and novel results, is an output that, in some sense, it has a high probability of being plausible in the context of the training data. And plausibility doesn't guarantee truth. And that's that is one of the fundamental, the other problem, that's one of the fundamental problems. The other one being that these systems are, in a sense, they're holographic. The information that is driving the output is stored in this matrix of neural network weights, which makes it very difficult to interpret why the output is what it is. So justifications are recovering justifications that are actually actionable is a challenge. This is the interpretability problem.
Yeah, sorry, that brings up like the need for knowledge representation.
Exactly.
And that's where I want to jump ahead and get a little bit into like, so out of that milieu you just described, and you also just kind of made the case, like, or the set up the situation for the modern neuro-symbolic architectures. But before that, there was this whole development of the field of like semantic, knowledge representation and semantic technologies. And the thing that most, you've been embedded in the Cyc community forever. Can you talk a little bit about how Cyc emerged from that milieu? And
yeah, no, this really starts. So, coming out of that Dartmouth conference you mentioned, there were a number of different ideas about knowledge representation that were starting to gel. Some of the most, four really essential names: Marvin Minsky, John McCarthy, Alan Newell, and Herbert Simon, were all in different ways thinking about what I think Newell and Simon call physical symbol systems, where essentially the idea was to create what amounted to be, something almost like a high-level programming language for representing knowledge, so that inferences, including common sense inferences, could be treated almost as the execution of programs. I mean, and this is very much, particularly through McCarthy, this is entangled with with the origins of programming itself, because one of the things that came out of this was the Lisp programming language, and the whole concept of S expressions on which that is built. And that was just an absolutely crucial development in the history of programming. And now, so now we come to the figure of Doug Lenat, who was actually a student of both Minsky's and McCarthy's and mentored by both men. And his idea was to take it one step further. And it's actually really interesting to see how this happened. This started back in, I think it was 1976 when Doug published his PhD thesis. That was I think it was, that was the automated, is something called the automated mathematician. And the idea was actually to build a symbolic program. It was based on on heuristics for theorem discovery. It was this was intended to discover new mathematical theorems. I mean, we hear about this a lot about generative AI doing this these days. This was much earlier than that, and it was symbolic, and it was using it was using it was using a kind of almost a kind of set of business rules for theorem discovery. And then in 1982, there was another publication from Doug. It was called, I think, Heuristics. Heuristics, the theoretical and experimental study of heuristic rules, that tried to expand the automated mathematician to more open-ended heuristics. That the upshot of that was a program called Eurisco. And again, this was about this was all not about theorem proving per se, but theorem discovery. But then then Doug had an epiphany of sorts. I think in 1984, he published a paper with J.C. Lee Brown that conceded that both AM and Eurisco were what Doug would later call ignorance-based systems. I mean, they were dependent on bespoke categories and rules that were kind of gaming discovery. In other words, you were gaming in effect, the system was being primed to discover, to follow paths that humans knew had been successful, but in a constrained sort of or ad hoc sort of way. And Doug wanted more than that. He wanted general knowledge to be involved. And he wanted a kind of a kind of representational evolution to be happening there, ontology evolution, if you like. And his belief was, he came to believe that the only way to achieve this was to try to formally encode as much of human common sense knowledge as possible. And the upshot of that was Cyc and the Cyc project and what eventually became Cycorp. And that started up around 1984. A really important thing, though, to bring out about it, that I think is often lost in discussions of the history of Cyc, and that is, it's clear, to me at least, the original intent of the system was to serve as a kind of set of guardrails and a development framework for machine learning. This isn't completely unlike the way ontology-based knowledge graphs are now seen as providing guardrails for large language models, except in Doug's mind, it was more, it wasn't, the guardrails needed to be there for the learning process itself, which was seen as operating continuously. And, whether or not large language models are actually doing continuous learning as a whole is a topic for another day. In any case, in 1984, Admiral Bobby Inman, recruited Doug to join the Microelectronics and Computer Corporation in Austin, Texas. And that was a very early AI effort that the U.S. government was supporting mainly through DARPA. I think it was intended to be a counterweight to Japan's fifth generation project, which was another early AI effort. And the U.S. government was somewhat worried the Japanese were going to get the drop on us in AI. So hence MCC. Neither of those projects actually resulted certainly in much. Certainly not AGI. But the Cyc project spun out of MCC in 1994 and incorporated Cycorp 3 years before I joined.
Nice. And so 84, that's like, the internet existed then, but that was about it.
The dark ages. Yeah, no, it was, I think it was, it was still sort of in the chronology. I'm a little hazy on the chronology, I confess, but I think that was like sort of the ARPANET era. It was certainly not in widespread use.
That sounds about right. Yeah. Well, that's so interesting. Well, I want to go a little bit into so Doug has this vision of capturing human common sense knowledge, like big things don't fit inside of small things. I don't, it's just mind-bogglingly vast to try to even predict what that.
Well, I mean, right. I mean, in some, yes, it was a vast vision. And this actually, I mean, in some sense, it raises a specter that is maybe haunting knowledge graphs to this day, I think, because in part, you touched on what I think is the key point here, and that is you can't predict. The idea, on the one hand, was to capture as much of common sense knowledge as humans could capture, really. I mean, Doug often talked of it in terms of white space knowledge. And what he meant by that was, in reading any unstructured natural language text, what is the framing background knowledge that you need to bring to bear in order to correctly interpret that text? And the aim, and it was an incredibly ambitious one, was to try and capture all of that, or as much as could reasonably be captured in Cyc. Now, whether or not that is a feasible enterprise is maybe the $64,000 question. But I mean, you can certainly do quite a lot with formal representations, especially if you confine yourself to delimited reasoning contexts or domains. But the problem of recognizing that you're in a particular domain that requires a certain model to be applied, and also critically recognizing that your situation is approaching, shall we say, the boundaries of one of those domains, because reality is always more inventive than human beings can be, it is a challenge. And how much of that problem can be dealt with formally, I think is still in some ways an open research issue. I will say right here, I am skeptical that it can be dealt with formally in its entirety. But this now, this now maybe gets us into the whole question of, what is the appropriate role for generative AI in connection with this, and how can these two very different conceptions be used in a way that is synergistic?
Yeah, I'd love to go a little bit more into that, but one thing I want to just quickly ask about is you mentioned like in convention in ontology design and engineering now, there's just this conventional wisdom that you constrain your ontology to a domain. You're very clear on what you're scoping it to. And maybe so that just seems like like sort of a pragmatic practice way of like, okay, this is crazy. The only way we can manage this is by constraining it to a domain. Is that what's going on there in terms of modern ontology practice?
I think, yeah, no, I think that that is absolutely right, with the proviso that this opens up the whole question of I guess you would call it cross-domain interoperability, which is it's almost like the sort of the whole issue of trying to bring semantic layers to bear in doing federated querying across data silos. Only now we're not dealing with data silos; we're dealing with knowledge silos. And here I think there really is there is a role for upper ontologies, things like the basic formal ontology that Barry Smith and Pierre Grenon created within the semantic web framework. And I think I am firm in my belief, and I think it's warranted belief that the upper ontology of Cyc can also help us here. And I think there are a lot of ideas embodied there.
So is that the starting point for your attempt to get the Cyc lore into RDF?
Yeah, yes, it is, absolutely. And I think that it's not as insane an exercise as it might sound at first. I mean, again, as I think the BFO, the basic formal ontology, indicates. I mean, that actually, says so. Another critical piece of intellectual genealogy here. Pierre Grenon, who was one of the individuals instrumental in creating the BFO, was also worked at Cycorp for a time. And I mean, I would say that it's very. I can, looking at that ontology, I can, particularly in the occurrent continuant distinction there, I can see the intellectual heritage. It's very clear.
Yeah, are there, and that's in terms of timeline, this overlaps. It's kind of like starts way before the semantic web, but the people who contribute to the semantic web, some of them are involved in the Cyc project.
Oh, yeah,
they're all, yeah.
No, it's really it is really very interesting. I mean, probably the one name that is of most signal importance here might be R.V. Guha. Who was Doug Lenat's graduate student, if I'm not mistaken, and also his teaching assistant for a time at Stanford, where Doug was before he came to Texas. And it was he would go on to he was instrumental in the creation of the resource description framework. I mean, Pat Hayes also had affiliations with the project, and the Cyc itself was involved with some of the contracts that were connected with some of the DARPA efforts that fed into the creation of the semantic web. I mean, we were involved, as I recall, with DAML and OIL and some of these projects.
Yeah, that's right. DAML, that was a defense agency markup language.
Yes.
Yeah, and OIL, I can't. That was something. Yeah.
Oh, I've forgotten what that acronym stands for.
Right, but those were like kind of predecessors.
That was
right?
all of that. I think was in the development light cone of OWL. If you like, and the past light cone.
Yeah, that's so, and that's a whole other thing is getting. I mean, it's one thing to have the knowledge in there, but then to build logic into the ways you work with that knowledge, that's a whole other conversation. Hey, I want to go just a little bit like so those parallels with RDF and Cyc, is that like as you embark on this project, is it sort of like kind of just how knowledge representation works that leads to like some commonalities? Or are these, like you mentioned, RV Guha and other connections like that? Like I'm just curious if you can stitch together a little bit more of the parallels between the RDF world and the Cyc world.
Well, this is really interesting. So parallels and distinction. I mean, so it might be more fruitful to focus on distinctions first, because I mean they're important, but they may not be as important as they might appear at first blush. So one of the critical thing with Cyc, as you might imagine, for an undertaking that was intended to capture common sense. The representation language, Cyc is extremely expressive. It's important to distinguish. There are really sort of there are two representation levels there. There's the epistemic level, which is the level of ontological representation, and the heuristic level, which is something like the implementation layer. But and the epistemic level is very expressive indeed. I mean, if you really, in some sense, the expressivity, I think, is that of Lisp itself, because the whole system was built on Lisp. And so, among other things, that are two very important features that it has. I mean, number one, and this is kind of, I think, sort of a heritage of S expressions, the notation itself was prefix notation, which means that your operator, predicate, logical, connective, whatever, is in the arg0 position. That seems like a minor technical detail, but it's very important because it means that you can have predicates that have arity higher than 2. That's a critical distinction from object properties and data properties in the semantic web, where the whole conception is predicated on graphs, and the object and data properties, are essentially like the labeled edges within the graph. So that's one key feature. Beyond that, though, there is the whole question of what can be an argument to what, and Cyc is very permissive on this in some ways. It allows for quantification not only over individuals, but over classes and predicates, and indeed expressions generally. So it's the term of art here is homoiconicity. It has the homoiconicity of Lisp. Expressions can serve as arguments to other expressions, which means that you can have assertions about other assertions. And you can write rules that are quantifying over assertions, which means, at least in principle, you can have self-modifying representations, with all of the complications that implies. So, and in some sense, I get the feeling, although I'm not the person to really go into historical detail here, I think RDF was trying in some ways to stop that madness, to constrain the expressivity.
I was just going to ask about that, because the way you describe it,
the semantics is badly. Yeah.
Yeah, you can imagine the power that entails. But and I wonder if, like you just alluded to, the simplicity of RDF, which is just subject, predicate, object, and that's the units you have to work with. And then now with RDF 1.2 and RDF star, you can look at triples as things. Well,
see, here is the thing, because as people have found, I think as folks have found occasion for saying more and more complex things using RDF graphs, what's happened is the system is getting extended. In some ways, it's kind of, one gets the impression it's kind of grown like Topsy. But, you now have extensions like RDF 1.1, which lets you deal with named graphs. So now you've got abstract individuals in the system that are effectively reifying entire graphs and associated with that. And then I think RDF star, if I'm not mistaken, this is now we're getting into areas that I confess I'm only just learning about, but I know that there are extensions like RDF star that allow for for actual quoting of triples. So now you do have what are effectively assertions about assertions. And I'm not sure with some of these. I mean, with named graphs, at the very least, the triple has to be somewhere in the default graph structure of your repository, as I understand it. But with the quoting, I'm not sure even that is respected. You can talk about hypothetical or counterfactual or entailed triples. And that so now you really are starting to verge closer and closer, I think, to something that is, almost it's like the lambda calculus, or you can, to something that, where you can potentially recreate both, both Russell's paradox and Gödel's proof. So,
Hey, I'll just mention that a few episodes, I think 2 or 3 episodes back, I had Ora Lassel and Adrian Gushvent on to talk about RDF 1.2 that talks about some of that. But hey, I can't believe it, Ben. We're already coming up on time.
Okay.
But before we wrap up, I just want to make sure, is there anything any loose ends you want to tie up from the conversation, or anything you want to make sure?
Oh, the loose ends. I mean, I think that, again, I guess one thing I would circle back to is just the importance of complementarity. And I mean, we've got these two very, very powerful frameworks, paradigms. I don't know even what's the best name to use. But I mean, on the one hand, you have symbolic AI, which is really formal logic. I mean, essentially, what the reasoning is very much like, some would say, actually is program execution. You have, justifications are auditable and debuggable. And provided the reasoning domain is circumscribed, truth of premises guarantees truth of conclusions. But the more complex it gets, and particularly the more self-referential it gets, the more complicated the semantics become, and the more expensive the reasoning becomes, frankly. And reasoning, and you've got this problem we mentioned, that reality is always more inventive than we are, which means you often have to revisit the underlying ontology. It's not, development is not an entirely front-loaded process, and adjusting the ontology over time is hard. NL, and then the NL understanding and generation is a whole other problem we haven't talked about. But it involves a translation, lexical translation layer, so that's an additional complication. Subsymbolic AI understands NL in a very real sense. I mean, this is something that effectively is passing some approximation of the Turing test. It's flexible. It can deal with probabilities. It's in some degree adaptive. Questionable how adaptive, but that's that's a topic for another conversation. But it's very good at generating useful hypotheses and extrapolations if you know what you're doing. But again, as I said before, you're getting plausibility. You're not getting truth. The central question is, can these two frameworks work together in a synergistic way? Where, in some sense, it's almost a kind of generative. What I'm envisaging, at least, is a kind of generative and test loop. On the one hand, LLMs are playing, it plays to the strength of LLMs, which is in some sense hypothesis generation, and to the strength of technical, formal symbolic AI, which is analysis and maybe writing herd on empirical testing programs. So, the question of what the architecture for supporting this would look like is an open one, and it's a research project that I'm really hoping to support and be a part of if I can.
Yeah, I think that's you won't be alone if that's any consolation. A lot of folks involved in that. Hey, one very last thing, Ben. If folks want to connect with you or follow you online, what's the best place to find you?
Well, you can find me on LinkedIn. I mean, just look for Benjamin Rode, last name spelled Rode. I'm there. You can also reach me at benjamin.paul, Paul.rode, Rode at gmail.com.
Cool. I'll put that in the show notes as well, of course. Well, thank you so much, Ben. This is really eye-opening, and I really appreciate your insights.
Well, thanks. I'm really glad to have this opportunity to talk about these issues.
For show notes and to sign up for our newsletter, visit our website at knowledgegraphinsights.com. And please rate and review us on your favorite podcast platform. Thank you for listening.